This is Module 1, Lesson 5. This is where we're going to be raising numbers in exponential form to a power. They've got the theoretical approach here, but I want to show you an actual example here. 2 squared raised to the 4th power. Do you see how we've got a base of 2? Hold on, let me get a pen that works. See how we've got a base of 2 here. We're raising that base of 2 to the 2nd power, and then we're raising this whole thing to the 4th power, okay? 2 to the 2nd power. If I've got 2 to the 2nd power, isn't that 2 times 2? Well, what this is saying is I take my 2 times 2, and I do that 4 times. 2 times 2, 2 times 2, 2 times 2, 2 times 2. This is 2 squared 4 times. What does that actually give me? It gives me 2 to the, and let's count them, 1, 2, 3, 4, 5, 6, 7, 8. That's 2 to the 8th power. How did I get there? What I actually did is I said, when I'm raising a power to a power, I multiply the exponents. You know, when we were multiplying bases, we added them. Now we're raising this to a power, so I multiply the exponents. That gives me 2 to the 8th power, okay? Now, what if let's do one more of those. What if I had 3 to the 2nd power raised to the 5th power? 3 to the 2nd power would be 3 times 3, isn't it? I would do 3 times 3 5 times. 1, 2, 3, 4, 5. That is 3 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 power, 10 power. Isn't that the same as saying 3 to the 2 times 5? That would be 3 to the 10th power. So when you're raising a power to a power, you multiply the exponents. Here's your theoretical approach here. When I'm raising x to the m power, and I'm raising all of that to the nth power, that's x to the n times m. Okay, now let's try a few of these down here. Now let's try all of these. 15 to the 3rd power raised to the 9th power. That would be 15 to the 3 times 9, or 15 to the 27th power. How about negative 2 to the 5th power raised to the 8th power? That would be negative 2. That's my base. Raised to the 5 times 8 power, 8 times 5, so keep this in parentheses. 8 times 5 gives me 40. That's negative 2 to the 40 power. 3.4 to the 17th power raised to the 4th power. So 3.4 is my base. I'm going to raise that to the 17 times 4 power. So what I do is I need to multiply 17 times 4. 7 times 4 is 28. 4 times 1 is 4. 5, 6. That's 68. Okay, so that would be 3.4 to the 68th power. And then I've got s to the 17th power raised to the 4th power. It doesn't matter what your base is, I get the same thing. S to the 17 times 4, or s to the 68th power. Sarah wrote 3 to the 5th power raised to the 7th power equals 3 to the 12th power. Correct her mistake. Let's do that first. We know if we're raising a power to a power, we multiply. So that would be 3 to the 5th power, 3 to the 5 times 7 power, right? 7 times 5 is 35. 3 to the 35th power. There we corrected it. Write an exponential equation using a base of 3 and exponents of 5 and 7 and 12. That would make her answer correct. Okay? With a base of 3, and my exponents are 5, 7, and 12. I've got 5, 7, and 12. Didn't we just learn if let's see, 5 plus 7 is 12, isn't it? So if I have 3 to the 5th power times 3 to the 7th power, if I'm multiplying the same basis, wouldn't I add the exponents? Wouldn't that give me 3 to the 12th power? So whenever you're multiplying the same base, you add the exponents. 5 plus 7 is 12. Whenever you are raising a power to a power, you multiply the exponents. There's your difference, okay? Now we're going to look at, what if you've got two different bases in parentheses and you raise them to a power? If you do that, you distribute your power, okay? Here, let's try this one, 2a, and we're going to bring that to the 3rd power. There's two different things in here, right? There's a coefficient and there's a base. What I need to do is I need to distribute this exponent to both of those essentially. So that gives me 2 to the 3rd power times a to the 3rd power. 2 to the 3rd power, that's 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. That would give me 8a to the 3rd power. Let's try this one. Let's just distribute this here, okay? We're not going to complete it. We're just going to distribute it. That would be 11 to the 9th power times 4 to the 9th power, okay? How about this one? Okay, let's take care of this. I've got 3 to the 2nd power. I'm going to distribute this 5 to both of these. 3 is the base here. It's just like a variable, so I don't change it. So that would be 3 to the 2nd power times 5. See, I've distributed the 5 here. Since I'm raising this to a power, I multiply the two exponents. 3 is not an exponent. It's a base. It's not a coefficient, so I just leave it alone. Okay, how about the 7? I've got 7 to the 4th power. If I'm raising that 7 to a 4th power to the 5th power, that would be 4 times 5. This gives me 3 to the 10th power times 7 to the 20th power. Now let's see if I'd have done it. Let's distribute it so you can see it a little better. What if I have my 3 squared and I raise that to a 5th power times my 7 to the 4th raised to the 5th power? 3 to the 10th times 7 to the 20th. Same thing, right? Okay. Let's look at 9. Now I'm going to distribute my 5, right? 3 is a base. So I have 3 squared, and I'm going to raise that to the 5th power. See how I'm distributing that to this base? Now let's do it on this base. A to the 4 times 5, okay, so a to the 4th raised to the 5th power. 3 to the 2 times 5. A to the 4 times 5. Okay, that gives me 3 to the 10th, a to the 20th. Okay? Let's try this one. See, 5 is not your base here. It is a coefficient, right? So I've got to distribute that to that and to the x, because there's an understood 1 as a coefficient on that x. How's that different from that down here? See, this squared's on the 3, so 3 is the base. Here, 5 is not the base. 5 is a coefficient in front of the base. If I do that, I wind up with 5 to the 7th power times x to the 7th power, because 7 times 1 is 7. Okay? Is 5 a base here? No, it's a coefficient in front of the base x, right? X has an understood exponent of 1. So let's distribute our 7. That would give us 5 to the 7th power times x to the 1st power raised to the 7th power times y to the 2nd power raised to the 7th power. Whenever I'm raising it to a power, that means I multiply. That's x to the 1 times 7 power y to the 2 times 7 power. That gives me 5 to the 7th power, x to the 7th power, y to the 14th power. Okay? And then let's do exercise 12 down here. I'm distributing this 4 here. A is a base, B is a base, C is a base. There's nothing above B, so that is to the 1st power. That's A to the 2nd power raised to the 4th power times B to the 1st power raised to the 4th power. See, I'm distributing my 4 times C to the 3rd power raised to the 4th power. So I'm going to multiply these. This would be A to the 2 times 4, B to the 1 times 4, C to the 3 times 4. That gives me A to the 8th, B to the 4th, C to the 12th. All right. And then let's look at this one. Powers of the monomials. We're just going to look at the odd ones here because you're going to be doing the even ones as homework. Remember, guys, if I'm doing this and when I've got a base, an exponent, and I'm raising it to a power, I'll multiply the exponents. The base is x, the exponent's 2, it's being raised to an exponent of 5, right? So that's x to the 2 times 5, which is x to the 10th. How about this one? I'm going to distribute this 3. Now let's remember, the c by itself means c to the 1st power. That would give me c to the 1 times 3, d to the 2 times 3. That's c to the 3rd, d to the 6th. How about number 5 here? Okay, now look, this is a coefficient. It's in front of your base, your variable. So we distribute this to the coefficient. We distribute it to this one, and we distribute it to this one, to the y there. That y has an understood 1 exponent. So I get 2 to the 5th. Then x squared, I'm going to raise to the 5th power. And y to the 1st, I'm going to raise to the 5th power. That's 2 to the 5th. That is x, 2 times 5 is 10. X to the 10th. Y, 1 times 5 is 5. Okay? And then let's look at number 7. This is a coefficient. It's not a base because there's no exponent above it. We're going to distribute this 4 to each of those. I've got negative 4 to the 4th power. C, 3 times 4 is 12. C to the 12th power. 4 times 4 is 16. D to the 16th power. And then let's do this one. This is a coefficient in front. It's not a base. We're going to distribute this to each one of these. Okay? That would be 1/2 raised to the 3rd power. A raised to the 3 times 3, which is 9th power. B raised to the 4 times 3, which is 12th power. C raised to the 5 times 3, which is the 15th power. Okay? Simple enough. And let's look at one more page here. I think I've got some on. We're going to look at one of each of these. If I'm raising something to a power, I multiply the exponents. In this case, I'm raising x to the squared to the 8th power. So that's x to the 2 times 8, or x to the 16th power. Okay? If I've got multiple things in here, product, then I distribute my exponent that I'm working on here. So we'll do one of these. there's a coefficient in front, so I distribute it to it. I distribute it to this base. You know, there's an understood one on the y and the z there. I distribute to those, okay? That gives me 4 to the third, x to the third times 3, so that's x to the 9th, y to the 1 times 3, so y to the third, and z to the 1 times 3, so z to the third, okay? What if I'm dealing with a fraction or a division problem? Once again, I would distribute my exponent. In this case, we would be looking at 3 to the second power divided by 5 to the second power. And they may actually want you to continue on this one. 3 to the second power is 9. 5 to the second power is 25. Okay? Let's look at this one. Now, I've got my product up here, so I need to distribute to the coefficient and to this base. And I've got to distribute down here to this base. That would give me 2 squared, a to the 10th, over b to the 14th. 2 squared is 4. So 4 a to the 10th over b to the 14th. The rest of these you're going to finish, okay?